Okay, let's begin. Today's paper is May June 2024, and this variant is 3.2. Okay, I was just scrolling through the paper, which is why it's there. There is May June 2024, and the variant is 3.2. Okay, let's start solving. Okay, the first question is sketching. This sketch x minus 2a. I've told you to sketch as a set of two lines. So one line is going to be x minus 2a and the other line is going to be minus x. Okay, now a is arbitrary, so you could plot it in either in whichever way you want. What I'm going to do is I'm going to label 1 centimeter as a and see if that helps me. Okay, so this has a y-intercept of minus 2a and x-intercept of 2a, I think. So this line is going to look something like this. For the other line, I'm going to draw it in red. It's the y-intercept is 2a and the x-intercept is also 2a. So that line looks something like this. Really, it should pass through all of these. Okay, so you keep the v that's visible and you erase the rest. That is your graph of modulus of x minus 2a. Okay, I don't know what stopped working. In any case, fix that later. Okay, then it says solve the inequality. This, what I need to do then is to, I always tell you that you should square both sides and solve. Okay, although it's easier in this case to just plug in the value, to just open it up with a plus and a minus. But I'm going to show you how to solve it by squaring both sides. So 3x square minus 8ax plus 5a square. I have to factorize this. 3 into 5 is 15. The factors have to be 3x and 3ax and 5ax. 3x, x minus a minus 5a. So I factorize this. I'm going to take out two roots and say that x equals to a or x equals to 5a over 3. I'm going to make a small sketch for a quadratic and say that this is a and this is 5a over 3. So I want less than 0, so x should be between a and 5a over 3. Okay, now although what I see in this question is that there's a modulus on one side. So ideally what I should do is I should plug in my answers and see if all of those are valid or not. Ideally I should take a value before a somewhere and a value after this somewhere as well, and check if those inequalities are valid. But this is a 2-mark question. My gut feeling is that you don't need to verify in this question. In fact, there is a verification. There should be a verification. Okay, so whenever there's a modulus on one side, that is what you should do. Okay, the better way of doing this question would then have been to sketch this line 2x minus 3a on this graph only. Okay, how do you sketch this line on the graph? I can say that minus 3a is my y-intercept and my x-intercept is going to be x-intercept is going to be 1.5a. Okay, so this line would look something like this. Okay, so if it has a higher slope and this coordinate is going to be 5a over 3, okay, I can solve that simultaneously and also find that out, 5a over 3. Then I see that when is the line less than the curve? The line is less than the curve only in this region. Okay, what is this region? This is x is less than 5a over 3. That should be the answer. In any case, if you have done squaring both sides like I have done, what you should do is, I've told you this before, that whenever you have a modulus on one side and an expression on the other, what you should be doing is you should be verifying your answer. Okay, so what I'm going to do is I'm going to mark some values here. Okay, I'm going to say that this is 1.5a. This area is called 1.5a. I'll pick up a value in all of these areas. This is 0.5a, and this a is a positive constant. Yes, a is a positive constant. So I could take a 0 here, and let's say take 2a here. Okay, and I have to verify each of these numbers. So let's say we first verify 0. So minus 3a is less than 2a. Yeah, that area is valid. A minus 3 is 0 and 0 is less than 0.5a. That area is also valid. And then 2 times 2a minus. So a is less than 0. Not possible. So my answer is in 2 regions. Those are those 2 regions. So I'm going to say that x is less than 5a over 3. That should be my final answer. Okay, so whenever you have a modulus on one side and an expression on the other, that is what you need to do. Surprisingly long question. Okay, this is about partial fractions. What I see immediately is that there's a square, so it's an improper fraction. I'll have to consider that. The denominator is also not factorized, so that's the first thing that I need to do. So I will have to break up 24 into its components. 24 would be 8x plus minus 8x plus 3x would give me 24. I've done middle term breaking. If you don't understand that, that's what I've done. 4 x minus 4 and 2x plus 3. So 6x squared minus 9x minus 16, x minus 4 and 2x plus 3. It's going to break up into a plus b over x minus 4 and c over 2x plus 3. How do you find a? You divide the highest powers only. Okay, so the highest powers are 6x square and the denominator square. That's a total of 3. 3 plus b over x minus 4 plus c over 2x plus 3 x minus 4 b minus 1 2x plus 3 plus b 2x plus 3 and c x minus 4. This should equal 6x square minus 9x minus 16. This and that cancel out. So I have this. I'm going to do a cover up method. Find out the partial fraction. So x is equals to 4. Okay, putting all of this on a calculator now. It's a really weird number. Yeah, I calculated this wrong. 44 is 4. Then in the next bracket, I have to take x as minus 3 over 2. X into 9 divided by 4. Okay, so my partial fractions are 3 plus 4 over x minus 4 minus 2 over 2x plus 3. Okay, let's check. Okay. Three minus 2 and 4. Yeah, those are the correct answers. Question number 3 quickly. Question number 3 says the variables x and y satisfy the equations where a and b are constants. The graph of y against x is a straight line. So take ln on both sides. Two y ln a minus ln a x ln b minus y ln b. Y against x. Okay. So 2y ln a plus y ln b equals to x ln b plus ln a. 2y, let's take y as common, 2 ln a plus ln b equals to x ln b plus ln a. Y equals to x ln b over 2 ln a plus ln b plus ln a over 2 ln a plus ln. Okay, so I have it in the form y equals to mx plus c. Y-axis is y, x-axis is x. Okay, and I have m and c in front of me. Given that a equals to b cubed, state the equation of the straight line in the form y equals to px plus q, where p and q are rational numbers in their simplest forms. Okay, so why don't I just do this? I have the equation in the straight line. I just need to 2 ln b cube plus ln b plus ln b cube 2 ln b cube plus ln b. Ln b, and that's going to be 6 ln b plus ln b, so 7 ln b plus 3 ln b over 7 ln b. Ln b, so 1 over 7x plus 3 over 7. So I've equated, yeah. Yeah, 1 over 7 and 3 over 7. Those are the correct answers. Quickly move on to question number 4. Question number 4 says the equation of a curve is this, find the gradient. So this is a question on implicit differentiation. So use y, v is e power 2x, u dash is 1 dy by dx, v dash is 2e 2x. So u dash v plus v dash u, that's the first term, that's the differentiation of the first part. And then I have u as y square, so u dash should be 2y dy by dx. And v as e power x, so v dash should be e power x only. So u dash v plus v dash u and when you differentiate 6 you get 0. Find the gradient of the curve at the point where y equals to 1. So y is 1. What is x? I will also need x, I think. Yeah. So 1 e power 2x plus 1 e power x equals 6 e power 2x plus e power x minus 6 equals to 0. This has to be a substitution. U equals to e power x, u square plus u minus 6 0. U is therefore equals to either minus 3 or 2. E power x cannot be minus 3. E power x has to be 2. I think my pencil stopped working. You will have to give me a few minutes to charge this. Okay, so I then have e power x as 2. I need e power x, I don't even need x. So I'm just going to use e power x and say that 1 dy by dx is what I'm trying to find. E power 2x is just going to be 4. 2 times 4, 1 plus 2 times 1, 2 and 2 into 1. Okay, so I get 4 dy by dx plus 8 plus 4 dy by dx plus 2. So 8 dy by dx equals to minus 10. Dy by dx equals to minus 10 over 8 minus 5 over 4. Oh, that's the correct answer. Yeah, minus 5 over 4. Okay, just give me a few minutes. I will be back after charging this pencil. Okay, I think we should be good to go. We are on question number 5. It says that it is given that e power 2x equals to 5 has only one root. Show that by calculation. So first you need to convert it into a function and say that this is this. Then once you need to plug in 0.7 and once you need to plug in 0.8. I'm going to do those on my calculator, hoping that my calculator is in radians already. Yes. 2 into 0.7 minus 5 minus cos 3 times 0.7. Point 69043. Change of sign indicates root. Okay. Okay, show that if a sequence of values is given by the iterative formula converges, then it converges to the root of equation. So what I want to show you is that this equation is the same as the other equation. So I'm going to first remove the subscripts. So x ln 5 plus 3x. Reverse the ln cos 3x, sorry. Five plus cos 3x. And I think I have the equation. Yeah, proved. I use this iterative formula to give the result of each iteration. So I'm going to use x1 as the interval that I found in part 1, 0.7 and 0.8. So that means I need to use 0.75. Okay, I type 0.75 on my calculator. That gives me 3/4. Then I type in 0.5 ln 5 plus cos 3 times 0.3 times answer. Okay, 0.73759. Okay, so I think I have the root 0.740. Okay, question number 6. Question number 6 says the diagram shows the curve this and its maximum point. Find the exact coordinates of M. So if this is a question on differentiation, I will have to apply the product rule. Dy by dx equals to u equals to x and b equals to power minus ax. U dash is 1, v dash is e power minus ax into minus a. Dy by dx u dash v plus v dash u, okay, equals to 0. E power minus ax is common, so 1 minus ax plus 1 minus ax. So either this equals to 0 or that equals to 0. Okay, I hope that's the correct. That's correct. Exact coordinates. I also need to find the y coordinate. Okay, 1 over power a power a sorry a only a power 1 a could cancel that. 1 over a, yeah. X and y coordinates done, and the exact value. So this is integration by parts. Pilot. I have an algebraic and I have an exponential. So use x. V dash is e power minus ax. U dash is 1. V is e power minus ax over minus a. Okay. Vu minus integration of du dash. V u v u dash. So minus x over a e power minus ax plus 1 over a outside power minus ax. I integrate that, that becomes e power minus ax over minus a. and I need to apply the limits 0 to 2 over a. Okay, it's easier for my limits if I have this as common. Okay, so upper limit a square. The upper limit, lower limit gives me just e power 0, 0 over a minus a squared. So that gives me e power minus 2 minus 3 over a squared plus 1 over a squared. Okay, so I have a squared 1 minus 3 e power minus. Does it say anything? It says exact value. I think that should work. Yeah, that should work. Correct answer. Okay, trigonometry. I see a simple solution there. And since we repeat it so often, I think everybody should see it. Okay, so that becomes cos 2 theta, and that becomes cos 2 theta. Okay, then this should become cos 2 theta, and that should become 4 sine theta cos theta squared. Cos theta, sine theta cos theta is basically sine 2 theta divided by 2 squared. That means 4 sine squared 2 theta over 4. So this 4 once again. So what you're integrating is basically cos 2 theta sine squared 2 theta. Now cos 2 theta is simple. That would integrate to sine 2 theta divided by 2. For sine square 2 theta, you would first have to employ the identity cos 4 theta. 1 minus 2 sine square 2 theta. Yeah. The sine square 2 theta would basically be half minus half cos 4 theta. That would be half theta minus half sine 4 theta over 4. And what limits do I have? Minus pi over 8 to pi over 8. So that would be sine 2 pi over 8 would be pi over 4 over 2 plus pi over 16 minus 1 over 8 sine pi over 4 pi over 2. The lower limit, I should have written that to the left. Upper limit would be sine, that was the upper limit. The lower limit would be sine minus pi over 4 over 2 minus pi over 16 minus 1 over 8 sine minus pi over 2. Okay, so sine pi over 4 is root 2 over 2, so that gives me root 2 over 4. Sine pi over 2 is 1. Okay, what's sine minus pi over 4? That should also be minus root 2 over 2. So minus root 2 over 4. minus pi over 16, and that last one has to be a minus 1, so minus 1 over 8. So root 2 over 4 plus pi over 16 minus 1 over 8 plus root 2 over 4 plus pi over 16 plus 8 and minus 1. 8. I put all of that right. I get root 2 over 2 plus pi over 8 minus 1. Yep, correct. Question number 8. Is vectors. Okay, the points A, B, C have coordinates this, where O is the origin the line L1 passes through B and C. Find the vector equation of line L1. So I'm going to first calculate BC and say OC minus OB. Three, and minus. Okay, the line L2 has equation this. Find the coordinates of the points of intersection. So the first line is 5 plus 3 lambda, 2 plus 3 lambda, and minus 3 lambda. And the second equation is minus 2 plus 3 mu, 1 plus mu, 4 minus 2 mu. 5 plus 3 lambda equals to minus 2 plus 3 mu. 2 plus 3 lambda equals to 1 plus mu, and minus 3 lambda equals 4 minus mu equals to 1 plus 3 lambda. Lambda equals to 2 over 3. I'm just checking if that is correct indeed. No, that's not correct. So I need to check back. What I've done wrong. My equation fine. 5, 2 and 0, 1, 1 and minus 1. Okay, 3, 3 and minus 3 is also fine. Okay, I think that is the difference. Fine, I think I should get the correct answer at the end. Mu is equals to, I think that's fine then. Setting off, so. Okay, then R is therefore 5 plus 3 times 2 over 3, 2 plus 3 times 2 over 3, 7, 4, and minus 6. Minus 2. Clear. Okay. The point D is on L2 such that AB equals to BD. Okay, I'll have to write down the vectors because this is going to take me some time to do. Minus 2, 1, and 4. 5, 2, and 0. And since D is on L2, going to have the general coordinate of L2. It's going to be minus 2 plus 3 mu, 1 plus mu, 1 plus mu, and 4 minus. So the distance AB. And the distance BD. BD. Okay, so that's going to be 49 plus 1 plus 16. 3 mu minus 7 whole square. Okay, that's a lot of expansion here. And 66. So 0, 9 plus mu plus 4 mu is 14 mu squared minus 42 plus 2 is minus 40. And 15 plus minus 40 and minus 6. Minus 56. And then 14, 49 plus 1 plus 16 on the right hand side as well, and the right is 0, surprisingly. So 14 mu minus 4. Either mu equals to 0 or mu equals to 4. So D should be then minus 2 plus 12 is 10. 1 plus 4 is 5, and 4 minus 8 is 9. Maybe I made an error somewhere. There's 60. I got 656. Four minus 2 or no, 8 minus. Okay, so I can't divide 14 by 60. Mu equals to 0 or mu equals to 60 over 14, which is 30 over 7. It looked like a really good answer, so I just went with this flow. 30 over 7. 30 over 7. Ninety minus 14. 76 over 7. 37 over 7. And 8 minus 6. Weird answer, but that's the right answer. Question number 9 is complex numbers. Press ZW in the form this. So 1 minus I, so minus 3 plus 3 root 3I plus 3I squared. Okay, yeah, I think that should be right. 0, 3 minus 3 and 3 plus 3. Express Z and W in the form give the exact values of our case. So I need to find the modulus and argument. So for Z, R equals to root of 1 square plus 1 square, which is 2. I need to know what quadrant it is in. It's real, positive, imaginary, negative. So it's in this quadrant. Okay, tan inverse of 1 over 1 gives me pi over 4. But argument is negative because it's in fourth quadrant. So Z can be written as root 2e minus iota pi over 4w. I have R as 3 squared plus 3 root 3 squared. R equals. Real is negative and I think that's pi over 3, yes. So theta is going to be, alpha is this. Theta is going to be pi minus pi over 3. So W equals x e 2 pi I 2 pi. Okay, on an organ diagram, the points representing W, ZW, and AB are A and B are A and B respectively. Prove that OAB is an isosceles right angled triangle where O is the origin. So it's isosceles at A. That's a right triangle as well, which means that the Pythagoras theorem must fit, and the sides should be equal as well. So W, the coordinates are minus 3 comma 3 root 3. I'm going to use basic distance formulas and calculations to prove to you that this is isosceles. And that's a perfectly fine way of doing it, although it's the longer way out in this case. But I can find out OA. OA is 3 root 3 minus 0 squared plus minus 3 squared gives me 6. Okay, I can find out OB as well. That's 3 root 3 plus 3 squared plus, I'm not finding a vector. Okay, that's e squared 6 9 to 70. That can't be true. It's right angled at A. Okay, then that can be true. AB is then 3 root 3 minus 3 root 3 plus 3 minus 3 root 3, so that's 3 squared plus 3 root 3 minus 3 minus minus 3, so that's 3 root 3 n squared, that gives me 6. So I've proved to you it's isosceles because OA and AB are same. And there's working there that I could have done. I don't need to show you an diagram in this case. And Pythagoras theorem fits. So root of 72 squared equals to 6 squared plus squared. So OB squared is the same as OA plus OA squared plus AB squared. I think that is what the marking scheme should also say. The question does not require the diagram. If they use 5, 5 or 12, they need to demonstrate. Okay, so I've proved to you this. There should be alternate ways of doing it. 1 mark for isosceles and 1 mark for right angle. There will be alternative examples. Yeah. Okay, so I could have done Pythagoras theorem and done that. I could have also used arguments to show you that, but I didn't, because I find it easier to prove these questions with trigonometry and basic algebra. Use your answer to part B to prove that tan pi over 5 pi over 12 pi is equals to root 3 plus 1 and root 3 minus 1. Okay, so my diagram doesn't have all of that. So in this case, I'm going to have to draw the diagram. In fact, just say this. Okay. Yeah, I think it's related to the idea that this 5 over 12 pi is basically the argument of ZW, I think. If I were to find the argument of ZW, I would see that that's 5 pi over 12. Because that's the only thing remaining in this question. I found out all of the arguments. Argument of ZW. So ZW was 3 root 3 minus 3 and 3 root 3 plus 3, right? Okay, 3 root 3 minus 3 means that it's in the it's positive, and that is also positive, so it's in the first quadrant. So it's just tan inverse of 3 root 3 plus 3 over 3 root 3 minus 3. Okay, if I want to calculate according to the rules, it becomes argument of z plus argument of w. So tan inverse of root 3 common plus 1 and root common root 3 minus 1. Okay, so what's argument of z? That's what I've already found before, and that's minus pi over 4. And this was plus 2 pi over 3. Okay, and inverse of now that I cancel out the 3's, I get root 3 plus 1 and root 3 minus 1. What's 2 pi over 3 and 2 over 3 minus over 4? 5 pi over 12. Okay. In question number 10, it says y equals to sec cube theta as 1 over cos cube theta. Show that this. I think that's simple. Cos theta power minus 3 and dy by d theta should be minus 3 cos theta minus 4 and then minus sign. And cos power 4 theta. Okay, the variables x and y satisfy the differential equation. This, it is given that x equals to 3 and theta equals to pi over 3. Solve the differential equation to find the value of cos theta when x equals to 0. Giving your answer correct to 3 significant figures. Okay, let's see where this goes. So sine theta over cos 4 theta d theta equals to x plus 3 over x squared plus 9 dx. This is the differential of this, so it should integrate back to sec cube theta. Okay, that's the thing that's pretty clear. For this one, you will have to first write this as this, because I see that the denominator makes it a tan inverse integration. The first part is then integration by recognition. I need a 2, I need a half outside, so this half ln x squared plus 1. The other one is 3, and then it's tan inverse, so that's 1 over 3 tan inverse of x over 3. That's the integration, that the formula that you must have learned, and there's plus c. So 1 over cos pi over 3 cubed of ln 9 plus 9. Okay, what's cos pi over 3? That's half, I think. Half cubed is 8. 1 over 8, so 8 half ln 18. Tan inverse of 1 is pi over 4 plus c cos theta. C is 8 minus ln 18 over 2 minus pi over 4. A little weird, but let's try to work with it. So sec cube theta equals to half ln. Now I want x to be 0, and tan inverse of 0, 8 minus ln 18 over 2 minus pi over 4. So 1 over cos cube theta. Half ln 9 will be ln 9 power half. Tan inverse of 0 is 0, plus 8 minus ln 18 over, I think, over 2. Okay, I just want to check if we're going down the right road. Yeah, I think it looks reasonably fine to me. I was wondering why it's 3 over 2 and not half. Where am I starting something? Three x plus. Okay, I think I've missed out on this 3. Yeah. Okay, yeah, the rest of it is fine, but when I have 3 here, I should have a 3 here, and 3 here, and a 3. Okay, let's see if we get the correct answer. I'm not absolutely sure I've done this correctly, but uh, 1 over cos cube theta. This is 1 pi over 4. 8 ln 27, 18 power 3 over 2. That doesn't work. 18 cubed plus 8 minus 3 pi over 4. Is this an exact value or just a cube root? Okay, I don't need to find an exact value, which tells me that giving your answer correct to 3 significant figures. So I could do this directly on my calculator rather than wasting time on all of this now. So ln 27 plus 8 minus 3 pi over 4. Okay, so that's 4.604. 1 divided by answer. The cos cube theta is 0.217. Then a cube root of the answer, 0.601. So I've done it correctly, regardless of the fact that it's a little different from the marking scheme, but that's fine. Okay, that brings us to the end of the exam. Not a long exam. Okay, I will see you with another video in the next another paper in the next video. Please keep watching. Make sure to like and subscribe.